What's up, everybody? How you doing? How you doing? How you doing? Welcome to my video where we're going to learn how to take a power to a power. Lots of good things here about expressions, lots of good things about exponents. Do yourself a favor though, if you have not seen my last video, how do we multiply monomials, go back and watch that video. You're going to need it. When we talked about how do we multiply monomials, I gave you this formula here, which says if you multiply two pieces with the same base, you just simply add the powers. Well, let's look at some of these problems, which you can probably already do. Let's look at this first one. 3 squared squared. Well, 3 squared I know is 3 times 3, 9. 9 squared is 9 times 9, or 81. Now let's look at this next piece, 3 to the 4th. That's 3 times 3 times 3 times 3. 3 times itself 4 times. So I can write it like this. Now 3 times 3, 9. Times 3, 27. Times 3 for the final time, 81. Now you might be asking yourself, why are these two pieces the same? Well, that's because there's a rule that says if you take a power, like this power of 2, to another power, you can just multiply the powers. For instance, if I wanted to take x to the 7th to the 3rd, what I could do, I guess, is I could write x to the 7th 3 times. Well, we know when I multiply pieces with the same base, I just add the powers. 7 plus 7 is 14, plus 7 is 21. But that's actually not the easiest way to do this problem. Doing it this way would be applying this rule, what to do when you multiply pieces with the same base. But I'm going to show you a new rule today of what happens when you raise a power to a power. Well, realistically, when you take a power to another power, like x to the m to the nth power, you can just multiply the exponents. For instance, problem 3 is the same here as it was here. But what I could have done is rather than write it 3 times and add the powers, I could have just multiplied these two. For instance, if I take x to the 7th to the 3rd, when I take a power to a power, I multiply, and here, multiplying 7 and 3, I'd get x to the 21st. I could apply that here. Don't get confused, the base here is a number. But again, if you take a power to a power, you multiply. So I should multiply 12 and negative 2. 12 times negative 2 is negative 24. This would simplify maybe a little bit further, but for now, let's just leave it with a negative exponent. Here what I have is a little bit trickier. I have a product of two exponent to another power, a power to a power, and a power to a power. A lot of powers. Let's simplify this. Here, if I take a power to a power, I multiply. This would say 5 times negative 2, or z to the negative 10th, and here 3 times 4 would be to the 12th. Now I'm back to the old school rule. Look how I'm multiplying two things with the same base. When you multiply two items with the same base, you add the powers, and this would become z squared. Let's see if you can try one of them on your own. See if you can figure out which of these expressions is equivalent to x to the negative 8th squared. Again, what you have to do here is if you take a power to a power, you end up multiplying the exponents. So I'm going to actually multiply negative 8 and 2, and I should have gotten x to the negative 16th. Let's try another one. See if you can try this problem. Well, this is a two-part problem here. What I have to do is I need to take care of the inside first, and then I'll take care of the outside. Let's rewrite the problem. Here, when you take a power to a power, I have to multiply. So 2 times 3 would be r to the 6th. Then what I can do is I can take care of the outside here. 6 times negative 2 is negative 12. The final answer is r to the negative 12th. Let's try another one. See if you can figure out the answer to this problem. Well, again, if I rewrite this, this is another multi-step problem. First, I'll take care of what's inside of these bigger parentheses, and then I'll take the product. When you take a power to a power, you multiply. 2 times negative 2 is negative 4. Power to a power is multiply. Negative 1 times 4 is 4, or negative 4. Now we are taking two pieces with the same base and we're multiplying. This is not a power to a power anymore. When you multiply two pieces with the same bases, you add the powers. Negative 4 plus negative 4 is negative 8. Let's try one more. See what the solution is to this one. Well, this one's a little bit tricky because now what you have here is you actually have a product within the parentheses. I have 2 times x squared and all of that to the third. So this one's a little bit different. I'm going to do it an old school way. One way I could do it is I could write 2x squared 3 times since this whole piece is being taken to the power of 3. So let's do that. I'll write it 3 times. Now I can go back to my old school rules. When I multiply pieces with the same base, I add the powers. Well, 2 times 2 times 2, those are just coefficients, they're not exponents. I can multiply those. 2 times 2 is 4, times 2 is 8. And then when I multiply things with the same bases, x squared, and x squared, add the powers. 2 plus 2 plus 2 is 6. Here I got 8x to the 6th. Remember that the 8 came from 2 times 2 times 2, and then I added the exponents here because I was taking a product. Now there's actually an easier way to do this problem, which talks about what do you do when you have a product and you take it to a power. Let's look at that rule. This rule kind of talks about what happens when you take a product to a power. Here I have the product of a times b, and I've taken that expression to the n power, and if you look, what happens is they both get the exponent. So I could bring up that last example that we did. Problem number 10 is the same as problem number 9. I just want to take 2x squared and take it to the third power. Well, now I'm going to apply the rule. If I have a product to a power, all I do is I distribute this exponent to both of them. Essentially, they're both invited to the party. So like 2 is going to get the exponent, and x squared will get the exponent. Let's see what that looks like. That would look like this. Well, 2 cubed is 2 times 2 times 2. 2 times 2, 4. Times 2, 8. X squared cubed, when I take a power to a power, we just learned we multiplied. 2 times 3 is 6. And if you look, I get 8x to the 6th. Let's see if I can do this one. Here I have a product of 3 pieces. 3, x squared, and y. And they're all going to get this exponent of 3. When they get the exponent of 3, I highlighted it here in blue. And be careful with this one. 3 is not a power. This 3 here that's written in black is a base. So that's old school 3 times 3 times 3. Well, 3 times 3 is 9. Times 3 is 27. So this first piece here is 27. These two pieces say I'm taking a power to a power, so multiply. 2 times 3 is 6, so this is x to the 6th. Here this y had an imaginary exponent of 1. 1 times 3 is 3, for a final answer of 27 x to the 6th y cubed. And finally, I'm going to do the same piece here. I'll take care of the product last, and I'll take care of the exponents first. Let's first distribute the exponents. 2 will get the power of 3, as will z to the third. 5 will get a power of 2, and z to the third will get a power of 2. 2 to the third is 2 times 2 times 2, 8. Here, power to a power means multiply. 3 times 3, 9. Here, 5 squared is going to be 25, 5 times 5. And here, a power to a power means multiply. 3 times 2 is 6. Now I'm back to just a product where when I multiply things with the same base, I have to add the powers. Well, 8 and 25 I won't add. Those are just coefficients or regular numbers, so I'll multiply them. 8 times 25 is 200. Z to the 9th times z to the 6th. Multiplying things with the same base, add the powers. 9 plus 6 is 15. I should get 200 z to the 15th. Let's have you practice 3 before I get you out of here. See if you can solve this one. Well, when you take a product to a power, they each get the power. So the 2 is going to get the power of 4, as will x to the 5th. Let's rewrite the problem and do that. 2 to the 4th is 2 times 2 times 2 times 2. 2 times 2, 4, times 2, 8, times 2 again, 16. When you take a power to another power, you multiply. 5 times 4 is 20, for a final answer of 16x to the 20th. Let's try another one. See if you can solve this problem. Again, when you take a product, 3 and x cubed, to a power, they both get the power. So if I rewrite this and apply that, they should both get the power. 3 squared is 9. Here, a power of 3 to another power of 2 means multiply. That will become a 6, for a final answer of 9x to the 6th. Last question. See if you can figure out which of the following expressions is equivalent to this. Well, here there's a few pieces going on. There's a product of x to the fifth, and then there's this piece here to the fifth. Let's first take care of this piece here to the fifth, and then take the product with x to the fifth. So everyone's going to get the 5. Every piece in the product, that is. The 2, the x cubed, and the y. When I do that, it should look like this. Okay, 2 to the fifth is 32. It's 2 times 2 times 2 times 2 times 2. A power to a power means multiply. 3 times 5, 15. And y just got the fifth. There was maybe a 1 there. It became y to the fifth. Finally, when I multiply things with the same bases, add the powers. The only pieces here with the same base are x to the 15th and x to the 5th. When I add those, I should get x to the 20th for a final answer of 32, x to the 20th, y to the 5th, not squared. Well, I hope you've enjoyed this video and you've learned something. Until next time, bye.